Hey guys, welcome to Concept and Coding. This is Shreyansh. Today we are going to cover all behavioral design pattern in one video. As you have already seen that I have already covered all creational design patterns and all structural design patterns, right? So this is the only pending all behavioral design pattern in one video. So these are all the behavioral design patterns which I am going to cover today. And just one thing I want to say before I start, at any topic or any pattern you feel that I am rushing and your doubts are not clear, I would highly recommend that go and check the description section. You will find a dedicated video for this where you can learn in depth what problem it solves, what are the different examples, so that you can check the dedicated video. Okay, so let's start without wasting any more time. Behavioral design patterns. So what is behavioral design pattern? So behavioral design pattern guides how different objects communicate with each other effectively. So we have, let's say, two objects. How they can communicate with each other effectively. What does it mean? Means we have to distribute the task. Then only they will talk with each other, right? So we can say that how we distribute the task efficiently and making software flexible and easy to maintain, right? So when you distribute the task, then only they will get a necessity to talk to each other, right? So that's what behavioral design pattern is, that distribute the task efficiently such that your software system is flexible and easy to maintain. And sometime other says that how different objects communicate with each other effectively. Okay, so these are the patterns we are going to see one by one. Okay, so first is state pattern. What state pattern says that state pattern allows an object to alter its behavior when its internal state changes. What does it mean? So this is one object, or say that product. It has lot of behaviors, right? And it also has lot of states, state 1, state 2 and state n. So it starts with particular state, let's say state 1, and when any particular behavior is, you can say that, executed, it will change its state, right? So that's what the state pattern is, and let's see this with an example. You will get better understanding what I mean. So I have taken an example of vending machine, right? In the vending machine, these are all its behavior. These are all its behavior. Insert coin or dispense item. And what are the states? So there can be many states, but for simplicity I have kept only two states: working state and idle state. This is the idle state, working state. Okay. So now this object, vending machine, has vending states. Okay, so now what generally happen is that initially, let's say I have set the vending machine is in idle state. Okay, so now these are the different behaviors which they have to implement. Each state has to implement. So now during idle state, let's say insert coin behavior is implemented, right? Coin inserted. So what it does is it internally changes the product state. So we pass the machine in the parameter. So here I am changing product dot set machine state, right? So this is the machine state. So what I am changing it? I am changing it to the next working state. Okay. So in the working state, if this behavior get executed, dispense item, then it might change the product state to some other state. Okay. So that's what it says, that it allow an object to alter its behavior when its internal state changes. Okay. Second one is observer pattern. In the observer pattern, what we have is, in this an object, which one called as observable, maintain a list of dependents which are called as observers, right? So observable maintain a list of observer and notifies them of any changes in the state. State of what? Observable. If any state change, this observable notifies all its dependents. So this is the UML diagram right? But I will tell you with a simple this example. So here we have an observer and this is an observable. So observable maintain a list of its dependent which is known as observer. So these are all the observers, right? So it is maintaining a list of it. So that's why it has a. Okay. So what all the methods observable can have is add observer. We can add into the list. We can remove the observer from the list, and we have to notify all and some state where whenever this state changes or set data or anything, then we have to notify it. So this is an interface. So we have created a concrete class which implement this method. So add observer will add the observer into the list, remove observer, remove from the list, set data. So now let's say that example of notify, an item is out of stock. Now as soon as the item is added, let's say item plus plus, as soon as item is added, I have to notify all the observers. So I call the notify method. So in notify method, I am iterating over this list and call their update method, right? So when they will get an update method, they will start doing something, or maybe just let's say that they get a notification. Okay. Then we have a strategy pattern. What a strategy pattern says that, let's say that for a particular task, if you have different multiple algorithms, then what it says that it helps to define multiple algorithm for the task, and we can select any algorithm depending on the situation. Just say that this is a task, paying is a task. So I have created a strategy, pay strategy. So what are the different algorithms? One is like credit card strategy, you can pay via credit card. One is UPI strategy, you can pay via UPI. Another is cash strategy, you can pay via cash, right? Each has to implement this pay method, and their algorithm could be different of processing the payment. Now what a strategy pattern says that we can select any algorithm based on the situation. So now let's say consider a shopping cart which wanted to utilize this strategy. So here if you see that I am using this as an interface. So I am using this pay strategy. So now whether if somebody pass here, so here if you see I am not hard coded new UPI strategy, no, right? So I will use a shopping cart constructor, shopping cart, and in the constructor I will get pay strategy, and I will assign it to the pay object. Pay object equals to this object. So now whatever the client want to use dynamically, I want to use credit card strategy, I will pass it and use it, right? Then I will call pay method of this. So pay object, whatever, whether credit card strategy you have passed, I will call this pay. If UPI strategy is passed, I call this pay. Okay, that's what strategy pattern says, that select any algorithm depending on the situation, right? Then we have chain of responsibility pattern. So what chain of responsibility pattern says that allow multiple objects to handle a request without the sender needing to know which object will ultimately process it. So consider this as is that I have taken example of logging. So let's say that client has sent a message that hey, log this message, and it will pass to this chain starting from this object. Now the client doesn't know that this log message is gonna process by which object. Let's say this one object is info log class, another class is error logs, another class is debug logs. Client doesn't know that which one will process my request. So this request goes here. It will check, hey, info logs class, can you handle this message? If it says that no, then it will pass it. Internally, this class itself will pass it to error logs. Hey, error log, can you handle this log message? If let's say that yes, then it will return yes, I can handle it, right? So this is the example, this is the UML which we have. So here if you see that a log processor I have taken. This is an interface. So this is, I am creating this chain. So log processor, it's an interface where it keeps next log processor. What's the next it has to link? Okay. So this next log processor will be set through a constructor, and there is one log message, and it will say that a next log processor not equals to null. It will call the log message. We'll tell you. So now what are the child messages? Info log processor, debug log processor. If there are more, let's say error log processor, or if there are more, we can add it. But for now, I have said that, let's say there are two objects, info or debug. So now let's say that info log processor, first it will get what is the next log processor after you. So who is connected after you, right? So it will get it from the constructor, and it will set into its parent that this is the next after my, right? So this next will get set ultimately. Now when its log message is called, it will check, hey, can I handle it? If it can handle it, it will process the message and return. Else it will ask the parent that, hey, I cannot handle it, you check. So it will call its parent super.log message. So this method will be invoked. Now it will say that, hey, next log processor not equals to null. No, it is not null because this next one is set here, info log, right? It is set to this one, debug. So it will call next log processor dot log. So it will call this one. Hey, can you handle it? Yes, I can handle it. It will process the message, right? And what its next would be, let's say nothing, then it will put null. So if it is null, then if any further try to process, this will not get executed. So say this is the client, new info log processor starting with info. What its next I have said, next log processor is debug. Okay. Now for debug, what is the next I have said? Null. There is no one after this one. So I have created this chain. Now the client just call the log message and it send the message. Now it doesn't know who will process it. So this chain will go ahead and see which object will handle this message. Okay. Then we have template method pattern. Template method says that when you want all classes to follow specific steps to process the task, right? Let's say a task is to make a payment, and you want that these is the steps everybody has to follow. No matter what are the different ways to pay, everybody has to follow this 4 steps, right? But provide flexibility that each class can have their own logic in that specific step, right? So let's say for making a payment, there are 5 ways. Let's say credit card, UPI, and through cash. So all have to process this 4 steps, but what logic they will have there in 4 steps can be different. So that flexibility it provides. So this is what known as template method pattern. So here I have taken an example like, so payment flow. I have created an abstract class. So abstract class, we can define one method also. So this is the template method I have created. Let's say send money. So I am creating a template. Hey, if anybody has to send money, it has to follow this step. First validate request, then debit the money, then calculate the fee, and then credit the amount. So these are the 4 steps they have to follow. And all this 4 method, I have kept the abstract. The child can implement it and provide their logic, right? And if you see that this abstract template method I have created final, means no child method can override this send money. So everybody has to follow this step only if they are send money is called, right? So these are the child classes. Let's say pay to friend. This is one flow. Pay to merchant. This is another flow. So when you are paying to the merchant, might be you are like fee calculation logic might differs, or validation might differs. When you are paying to friend, certain logic differs. So this validate request, credit amount, debit amount, calculate fee, logic differs in this. So they have write their own logic for that. Now when anybody calls, let's say I want pay to friend flow. So I created a payment flow, this payment flow object, and pass this pay to friend object to it, right? So this is my reference, and what reference it holds of an object? Pay to friend. Now I am calling send money. So send money which one will be invoked? This one, because it's only present into the parent. So this method will be invoked. So first, validate request. So this is abstract. So it will call to its child one. Which child one? Pay to friend. So validate request, this one. Second step, debit, this one. Third, fourth. So it is following a particular template, following a particular step, but what logic within that step, that we can override. Then we have interpreter pattern. Interpreter says that it provides a grammar for interpreting and evaluating an expression. It is specifically for expression. Whenever we get a expression type question, interpreter pattern is something which is useful. But it is based on a context, or you can say that grammar. So let's say that consider this hand. So based upon the context, you will understand it, like what does it mean, right? So maybe if I am giving you a context that a traffic, then this signal you might interpret as a stop. If I give you a context that friend, then you might say that he might be saying hi, right? And if you are saying, if I give you something context like mathematics, then you might consider that this is 5. So what I'm trying to say is that the interpreting depend upon the context, what context it is. So right, interpreter pattern says that it defines a grammar, or you can say that the context for interpreting the evaluation expression. Take this an example. So when we are saying an expression, so expression has always two parts. Let's say A into B. This is an expression. So expression has always two parts. One is terminal and another is non-terminal. So this is non-terminal, and this further can be divided into two parts, like A multiply by B. Can this further be divided? No. So this is terminal. This is terminal. Okay. So consider this as an example. So this is a UML diagram for it one, and I can show you with this example of A into B only. So first we have to create an expression interface. In that we have to define interpret method. So this interpret is totally depend upon the context. I told you, right? Based upon the context, it will interpret it. What does it mean? So now expression can always have two things. One is terminal expression, one is non-terminal expression, right? So here I am doing A into B. For example, I have simplicity. I have said that multiply non-terminal expression. So multiply non-terminal, or you can say that non-terminal can have two things, right? Right? So it can be again terminal or it can be again non-terminal, right? Understand this one, like A plus B. So it has two parts, A and then again A plus B. So this is terminal, but this is non-terminal. Okay. So multiplication or non-terminal have again two parts, left expression, right expression. So, but this is again a parent interface, right? So it can be terminal, it can be non-terminal. Okay, this is just a constructor and its interpret method. So its interpret method is generally this information come, so I have specifically said that multiply, but we can make it more generic. So left expression into right expression. So left expression interpret. So now I am doing recursion. Left expression dot interpret, right, into context. So if this is a terminal operator, if this is a terminal, so this left expression dot interpret, if this is a terminal, so which one method will get invoked? This terminal one, because it has the object of either this or this. If this is a non-terminal, then which one will call? Again this, right? And it will keep on doing left right till everything is not resolved. Okay, so in the non-terminal here, if you see that we have something called value, this value gets set. Now here if you see that interpret, right, we have a context. So now it says that context dot get a string value. So now let's say that we have A into B. This A got set here, right, A. Now from the context I can provide that A, B. A means 2, B means 5. So this is the context I am sending. So here if you see that this is the context I am creating a map. So this is the context map. So A means 2, B means 5, something, right? So this context I am passing. So when it terminal operator get this, so context dot get, so from this context map it says that string value A, what is the value? 2. So it will get 2 here into, let's say write expression is also your terminal, so it will call this write expression context into get. So for write this value is set as B, a string value. So for B it get 5, so it will get 10. Okay, so this is how it is here if you able to see. So I am creating an expression A into B, right? So I am creating a multiplication expression, non-terminal expression. I am passing 2 terminal here with A here, and in the second one I am passing B. Okay, and I am passing this context which A means 2, B means 4. Got it? So that's how what interpreter pattern means. Then we have command pattern. So command pattern is also very interesting. So command pattern says that turns the request or command into objects. Why? It helps you to either parameterize or queue them. This will helps to decouple the sender and receiver. Very important. It helps to decouple the sender and receiver. So understand the problem first with this example. So here if you see in this is an object. And we have to give a command, let's say turn on AC, turn off AC, set temperature, something. So currently who is giving the command? This is the sender also. So this is giving command, hey turn on, turn off, set temperature. So today it is very simple, turn on AC, it will turn on. But let's say that if turning on an AC involve multiple steps, it's not just easy that you call this method. This air condition class might have exposed 10 methods, and you have to invoke, let's say out of this 10 methods, you have to invoke this 1, 2, 3 specific methods to turn on the AC. Then who has to have this knowledge? Sender. So it now turning on the AC, it has to perform this step 1, step 3 and step 4, then only AC will be turned on. Here in this example I have simply showed the method turn on the AC. But what if there is nothing like turn on? It's like turn on condenser, turn on this, turn on this. Then ultimately all these 3 steps start the AC. So currently sender has to know about how to turn on the AC, how to turn off the AC. So they are not decoupled. They are very tightly coupled. They cannot scale alone. Right? So that's what command patterns does that. What command patterns does that? Hey, this is a receiver, means this is an object. It has methods like how to turn on the AC, how to turn off the AC. Might be a single method or might be let's say 100 of methods. Doesn't matter. This is a sender. Sender doesn't worry about like how to start an AC. It just say that press button, command dot execute. Right? So I have created one command interface now. So whatever the command that can be done on this receiver, let's say one command is turn AC on command. Another is turn AC off command. If there are more, we can create more commands. That's why it says that create an object for the each command. So for each commands, we have created an object. Right? And now they will have the logic. Whenever we are calling the execute method of it, they will have the logic like how to turn on the AC. Now even if to turn on the AC, if there are 10 steps, they have to know. Right? So now in future, if let's say that one particular step is removed, then only this class will get impacted, not sender. Sender will just say that execute a particular command. So it will get the command from the client whether it want to do turn on the AC or turn off the AC. That command will get set, right? It's just an interface, and it will just say that execute. Now that particular, let's say turn off, that execute will get executed, and it has now all the logic how to turn off. Sender and now receiver are decoupled, right? All because of this command layer in mid. Understood? So that's what it is. Then we have iterator pattern. So iterator pattern provide a way to access element of collection sequentially without exposing the underlying representation of the collection. What does it mean? So this is a very best example in Java collection. So here if you see all this purple one, these are all collection. Now you can create a collection of anything. Collection is nothing but a aggregation of data, right? So I have aggregated the data. Each one has the unique way of storing the data. It is maintaining a linked list. It might be creating an array, right? So each one hold a list of data, but the way of storing the data is totally different. But if you wanted to access, this piece of logic is totally same for all. No matter where the data is stored, this logic, if you are trying to access it, this logic will work for all. How? Because they are using iterator pattern, right? So without exposing the underlying representation of the collection, it is storing as an array, it is storing as a linked list, it is storing as a hash map, right? So without exposing that, it helps to iterate the collection well. So how it done? This is how it's done. So this is something called collector. So let's say I have a book. So this is one book. Now there can be so many books, right? So I have just created one object called book. Now there is one called collector which collect this object. So for simplicity, I am creating a list of books. So this is a collector. Now this collector has to provide a way to access this collection. So it has to expose one method, create iterator, right? So whenever the create iterator method is called, it return this object. So what it is? So here I am creating one iterator interface which has two methods, has next and next. So let's say this is the array. Has next. So let's say currently you are here. Has next tell that, hey, is there any more data? Yes or no? Give me true, false. If yes, returns true. If no, return false. Next means that move the pointer. Okay. So iterator expose this two method, and there is one, we have to write a specific iterator. So we are writing a specific book iterator. So book iterator, whatever the collection it will get, it will provide a logic how to iterate it, right? So it has to provide the logic. Let's say if it is this is for simplicity, I'm using a list, but let's say if there's an array or linked list, then they provide its own logic, has next, how to look that next element is there or not. Then increase the pointer if there is a next element. Okay. So, but my point to telling you is that there is one specific iterator present which accept the list where it will provide helps to iterate it. So library, which is a collector, when create iterator is invoked, it has to return one of the iterator of this one. So it returning the book iterator, pass this collection to this. Hey, now those books iterator, it will iterate it using has next and next. That's what exactly same thing happens here. So this is an interface, and if you go inside this implementation, each of this class, you will see that you will find one ITR which implements this iterator, which provide this two method implementation. And then there we have array list or something which maintains an object. Let's array list, it maintain array, object array. If there you are using linked list something, linked list something, you will see that it maintain a linked list, right? And it will call that iterator and pass this collections to them, and you can iterate it. So this is iterator pattern, and this is a very good example with Java already using it. Then we have visitor pattern. So this pattern is very unique, where it says that it allow adding a new operation to existing classes without modifying them, and it encourage open clause principle generally. So what is the problem with the below class? So let's say I have a hotel room. In hotel room, these are the three methods I have already written. But let's say then these are already tested and live production. But let's say that more and more operations can come over the time, right? Then what you have to do, so currently hotel room, get room price for single room, for double room. So you have to keep changing the logic. So means we are already touching the tested code, the code which is already live. So you have to keep on testing this. Because you are touching the existing live code. And one more thing is, if you are changing in the price logic, then you might have to test this maintenance logic also, reserve room logic also, right? Even though you are not changing anything, but you are actually changing in the class. So you might have to test it. So this problem is resolved by the visitor pattern. Okay, so visitor pattern has two things, element and visitor. So element is an object like a room here, right? For which multiple operations can be happened, right? So visitor is nothing but a multiple where you can cap all the different operation. So this is visitor 1 means operation 1, operation 2, operation 3, like this. See this with a simple example, you will understand that. So I have created one element which is a room, right? So this room can have like single room, deluxe room, double room. There can be multiple rooms now, right? So now here if you see that it has the room visitor. So I have created one room visitor. The room visitor will now have kind of, this is an interface and all its child are like an operation. This is operation 1, operation 2, operation 3. So currently this is operation 1, room pricing visitor. This is second operation, room maintenance visitor, like some other operation, right? So each operation you are adding a new class now. So it exposes a method like called visit, right? You have a visit and they have to implement that particular visit class, right? So here I have 3 rooms logic, single room, deluxe room, double room. For simplicity, I have created three methods, right? But you can also have one method, and in one method you can have the logic which can handle all the 3 scenarios of single room, of double room or deluxe room. But just for simplicity I am saying that let's say 3 different type of room, 3 different method you can have, but now you can see that each one is a separate. So each one have their pricing logic would be here. Only maintenance logic for all single room, double room would be here, right? Or either you can create only one class visit and handles in that if else condition single room, double room, deluxe room, right? So now here if you see that if in future any new operation you have to add, as visitor pattern says that any new operations you have to add to an existing class, you can add without modifying them. Let's say I want to add new operation. Now can you add it? Yes, you can add it. You can add it into the visitor. You can add it a new operation here. So this will not get touched, this will not get touched. If you want to add a new room type, that also you can add without even touching this operation, existing operation. Right? So this is what visitor pattern is. Then we have mediator pattern. Mediator pattern says that it encourages loose coupling by keeping an object from referring to each other explicitly and allowing them to communicate through a mediator object. So any scenario where you want that two objects should not talk directly, instead they talk through one mediator, right? Then this pattern is useful. So consider a scenario of auction. So in auction, so this is an auction room where multiple bidders sit. So no two bidders talk directly, right? So in the auction, so there is an auction person, so they talk via this, right? So no two bidder talk directly to each other, but they talk via auction. So that's what example I have taken to explain you this pattern. So colleague is nothing but an object where you wanted that these two should not communicate with each other, and something called auction mediator, which is like through which this colleague should talk to. Okay, so in the colleague, here they have like place bid, receive bid information. Okay, so this is like set mediator, send message, right? And also one method is called receive message. Receive message from mediator. Send message to mediator, not to other colleague. So it is sending message to mediator, receiving message from mediator. So first we will have to set the mediator. So let's say in this example, I have created one bidder. I have set the action mediator, auction mediator, its object. Now place bid. So place bid considered as a send message to mediator. So auction mediator dot place bid, it send the bid to the auction, right? Receive bid notification, let's say that receive message from mediator. Now what does mediator do? So mediator has like add bidder. So first of all, it maintain the bidder. You can add more colleagues, you can remove the colleague out of it also. And second is place bid, right? So now in an auction, first I maintain a list of colleagues. So auction itself has to manage it, add, or let's say remove class also we can add. We can remove the bidder out of this collection also. Then what we have is that place bid. So place bid is like this one. So a bidder sending a message to the mediator through, let's say, place bid. Now once the auction get a message from one bidder, so these are all the bidders. So one has tell that send a message to a auction mediator. Now this auction mediator has to send the message to all other mediator. That's what it does. So it will iterate over the colleagues or bidders, and it will send receive bid notification message, this message, so that everybody receive the message from this mediator. So I have put this if condition so that the person who has sent it should not get it. Only others should get it. But you got this, right? When this design pattern comes into the picture, if in interview any question comes where two colleagues should not interact with each other, only they should interact through mediator, right? Then we have something called memento. So memento, from the name it is clear that it is called something called memory. So whenever a question, interview questions come where you have to maintain an undo capability, you have to you have to keep memory of the history, like some past information, undo capability. Then memento pattern comes into the picture. So it provides an ability to revert an object to a previous state, right? So how it does it? So Memento has three parts. One is caretaker, second is Memento, third is originator. So what is originator? Originator is an object for which state need to be saved, for which memory has to be taken. This is the originator. Then we have Memento. Memento is like what all things you need to save out of this originator. So it represents an object which holds the state of the originator. Like originator might have 100 things. So now let's say that out of this 100 things, only 50 things we have to store. So Memento is an object which has fields for this 50 fields that need to be stored. Caretaker, it manages the list of the state. So it manages the Memento. So this is how it's done. Okay, so so this is the UML diagram. I will explain this UML with this example. It will clarify you more better. So first I am creating an originator. So originator means with this I have to maintain a history. So this is my configuration originator. So in the configuration class I have height and width, right? So this is just a getter setter. Now this originator has this two extra method. One is create memento, another is restore memento. Create memento says that, I already told you the memento, that what does memento means? Okay, I have already told you memento, that memento is like what all information you want to store of this originator. So currently let's say that I want to store height and width. So even though let's say it has more fields, right? But let's say if I am only interested in this, so memento will only have this two fields. But for now I have just kept it same. Whatever the fields are there in the originator, I have the same fields in the memento. But memento only store fields which you actually wanted to store. And it has just getter setter. So now originator knows only that what all fields I need to store. Okay, so create memento. So it will take the responsibility of creating a memento. It will create a object of this memento, configuration memento, right? And it set whatever things it want to keep in a memory. For now I have kept like both height and width. I want to store it. So it creates its own memento. Similarly, another method is restore memento. When it's get the object of the memento, it will read out what all from this memento it has to read and set those fields back from the memento. So these are internal to originator, right? So that's why its definition also says that it do not expose the object internal implementation. From outside world, they will just call this originator and says that create memento. Now it will not expose how this object looks like, what are its field. It doesn't care. This will take care of itself because this is the same class, so it knows about its field, right? So this internal implementation are not exposed to the outside world. They will just create memento. And during restore memento, it will pass the memento and it knows how to restore out of it. Now, so you know originator now, you know memento just this. Now there is something called caretaker. So caretaker, what it does is it maintains it taking the care of what? Memory, mementos. So it is maintaining a list of mementos. So it has one method add memento. So whenever a new memento comes, it will add it into the history. It has one method like undo. So whenever undo method is invoked, what it does is from the history, it takes out one last memento and return it. Right? So it taking care of what? It taking care of this memory. It adding it and doing an undo functionality, returning the last memento. Now, so here if you see that now you can utilize this. So I have created this caretaker, I have created this originator. So this originator first has what field? 5 and 10. So first we are calling originator dot create memento. Now originator will create a memento and return this object. Now we will call caretaker and ask it to store it. Hey caretaker, store this memento. So caretaker now store this as a 5, 10. Now originator changing its state. So we have changed set height 7, 12. So this is now 7, this is now 12. So we are again asking originator to create a memento. So it will create a memento and return it. Now we are asking the caretaker to store this memento also. So it store this 7, 12. Now originator changing its state 9, 14. 9, 14. Now we haven't taken any memento or memory of it. Now we are calling undo functionality. We are calling caretaker and saying that hey undo. So caretaker will return 1, 7, 12 object, memento object, and this memento object we have passed to the originator. Hey, restored from this. So what it will do is it will restore, originator will restore 7 and it goes to 12. Right, so this will print 7, 12. Okay, so I have covered this all 11 behavioral design patterns. If you think that there are places where I rushed a bit, I would highly request you to go and check a dedicated video for each one. You will get a better clarity about the problem and UML solution of it. Right, advantage, disadvantage, everything. Okay guys, thank you, and if you have any question, let me know in the comment section. We can discuss more. Thank you. Bye.